मुझे आप होस्ट बना देना।
हो गया मेरे।
ओके, मुझे होस्ट बना देना।
ओके। ओके ओके।
Okay. So hello everyone. Welcome again for one more DIY session. In today's session, we will try to make a home automation system, and using this home automation system, you can control the appliances, and you can control the fridge, refrigerator, light, and you can even make a touch switch. And there are lots of things that you can make using this. Okay, you can design your own complete automation system using this. Okay, so let me first show you. Second. Yeah. So, oh yeah. So let me first show you the settings here, how I have set the things. Uh, yeah. Let me share my computer screen, desktop, share, hello. Okay, so my screen is visible to all of you. This is screen. Okay. So here I have done the setup. So this is a very simple basic setup of the home automation system that I have prepared. So what it consists is it has its the bulb here connected, the AC bulb. This is the AC bulb that I have connected, and then we have the a relay module here connected, and this is the Indus board coin. The Indus board coin has its own many sensors that we are going to use here in the automation project, and this is the AC light, and the relay is connected here. So let me tell you how the everything is connected in detail. So the component that you need is the very simple one that is basic. The one of the most basic component that you need is one here in this design is the one IoT board, that is IoT enabled board. And here we are trying to make it very compact and a small design that can fit inside the bulb holder, or that can fit inside the switchboard. So better to use the compact and a smart board, and that will also able to give you the lots of sensor integration, and also able to give you the enough GPIO pin, so that you can connect enough number of lights, like 5, 10, number 10, number 20 numbers of lights of the whole bulb in the entire room, or in the entire hall, in the entire house, or in the entire office. You need at least 20 to 30 bulbs. So it need to have that much of GPIO numbers for that, and it need to be a small. So only board that we get in this range that has enough number of GPIO, and also enough number of the a capability, and also have the different functional mode like the sleep, deep sleep, to save the power, and also has a different kind of sensors that help you in the home automation things, is the Indus board one. Because it's a small size, it's very compact, and it has integrated sensor, and there are 30 plus GPI over here. So and if after prototyping, you can make your own FPC board, or that will connect to your main board, and you can make a complete product around that. So here I have choose. That's why we have choose the Indus board coin here, because it has the sensors, and there are enough number of GPI that can able to control a lots of, that will help me connecting and control a lots of home appliances like the fan, refrigerator, TV, fridge, AC, and many n number of bulb. Okay. Okay, then the second thing that we need is the relay module. So there are two types of relay module out there in the market. One is the solid state relay module. Another is the mechanical relay module. So you can use any as per your preferences. So I am here using the solid state relay module. This work on the 5 volt, and it has a 3 output pin. It has a 3 output pin. Okay, so this thing is the DC. Here, this part is the DC. This part is the DC, and this part is the AC. Okay, so it has the NO pin, NC pin, and NO pin, NC pin, and common pin. Okay, so common pin is the one pin that will go to the live wire of the AC signal, and then NC is normally closed. So if you want, whenever the light is come on, and if you want that thing to be normally closed, then you can either use the normally closed or normally open. Okay, so you can connect wire according to your need. Okay, so here I have in my design, here I have connected that. You can see here in my design, you can see the AC line of the bulb, AC line of the bulb, AC line of the bulb connected. Okay, AC line of the bulb is connected. Okay, okay. So here in the AC line is of the bulb is connected. So I can power the relay module using the 5-volt pin on the Indus board itself, or you can I can directly connect the 5-volt adapter, and that will power the both the Indus board point and the relay module. Okay, and then the ground wire I have connected to the ground wire of this Indus board point, and there is the signal wire. That signal wire go to the signal wire of the Indus port card. Here I'm using pin number 33. So you can connect n number of these relay that, like if you want to control 10 appliances, if you want to control 12 appliances, then you can add all these GPIO different relay to all these GPIO and give the input and output for that. You can connect the sensor as well. However, you don't need much sensor because most of the sensors are there in built. So we are going to use the proximity sensor. We are going to make a touch switch board that, so we can also use these all the GPIO here you can see are the touch enabled. Okay. And okay, so let me show you the first demo of this. So let me first upload the code and let's show you the demo. Okay. So here is the code that we have prepared. So it is in STM mode. So it connect to, okay, let me connect the board here. We connect the board here. So I am uploading the code. So after that, I will tell you the designs, how we can make the touch switch board, how we can make the proximity, the motion sensor light control, how we can make the IoT dashboard, and using which wirelessly we can control it. But first, let me show you the demo of this. So this is the whole setup, as you can see here. This is the whole setup, and this is the AC wire. Okay, so this AC wire goes here in the AC input, the common, and the NO pin for the bulb. Okay, and the live wire goes of the to the bulb. Okay, directly. Okay, so neutral wire connect with the relay. You can either connect neutral or live, whatever it didn't matter. But here I am using the neutral wire that connect to the common pin, and the neutral wire of the bulb connect to the NC pin. Okay, and the live wire directly connected with the bulb, and that live wire and neutral wire then again goes to the AC line. Okay, this is the AC. This part from the here to this side is total AC circuit. Okay, this is the total AC system. Okay, and here totally things work on the DC. So it is taking the signal and processing everything in the DC current and the controlling the things that are AC appliances. And both things are electrically isolated and optically coupled using the optocoupler that is placed here in the on the relay module. Okay, so both circuits, AC circuit and DC circuits, are electrically isolated and optically coupled here. Okay. So let me see the code is uploaded or not. It seems like code is uploaded. Okay. Let me check with the Wi-Fi. Which code I have uploaded? This code. This code. Which code I have uploaded? This one, no? So this is the code I have uploaded. Let me check on my phone Wi-Fi is connected or not. So I'm checking my phone, the IP address. Actually, the code I have uploaded there, you need to do one thing. You have to make a static IP address or either print the IP address to whom it is connected. So you have to write the code here for that. But here I haven't write that code, so I am using the who on my Wi-Fi application to check who is connected to my Wi-Fi to check the IP address of the this Indus board connected Indus board. Okay. The better way is to use the static IP address. A static IP address will not change every time, and you will know that this is your IP address to access your IoT device. Okay. So let me check the IP address. Let me scan. I'm scanning the IP address here. So there are lots of devices connected to this network here in the search. Okay, let me try the IP address here in the Chrome browser. So when you enter the IP address here, it will open the dashboard like here. Okay. So I am entering the IP address of the find of the scan devices. One nine 2.168.166.2.9.76. Is it that? No, that is not 147. 147. 147. And that is about 9.9. 186. Let me try all the IP address. Better way to print the IP address on the serial monitor, but I have uploaded the wrong code. And otherwise we will try the AP mode. So IP address is not visible. Let me upload the another code then. Okay. So 1 minute. Let me upload the another code and modify this code to use. To use the IP address and display that IP address on the. Yeah. on the serial. Okay. So so for the relay side, you can either use this mechanical relay, or you can either use the solid state relay. Solid state relay, the benefit of using the solid state relay is that it didn't make much noise, and it is very smooth switching and very fast switching. If you are using this kind of relay, so if you are switching a lots of appliances at a time, it is making tick 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 different kind of noise, and it might be not good for you. Okay. So now I have the code here. Let me share you what are the changes that I am making. Okay, let me share you my screen. Let me paste my code first. Okay, where is my screen share? Which windows I was in? Here I got a screen. Sorry for the, yeah. Here I got a screen share. So I am sharing a screen. So I have made few changes on the code. I hope this change is visible to you. Okay, my screen is visible to you. So here you can see in this part of the code, earlier we don't know the IP address, we are using the third party application to get the IP address to whom it is connected. So here, 1 second. Yeah, here in the code you can see I am using the serial.println Wi-Fi connected. If Wi-Fi is connected, I am checking. And if that Wi-Fi is connected, that I am printing the IP address and get the Wi-Fi dot local IP address. So whatever the IP address my device is connected with, it can print on the serial monitor. So let's upload this code. So let's upload this code and check it out. Oh, sorry. There is a mistake. There is a mistake here. Let me upload the code again. This is the STA mode one. This is the code. Yeah. Here I need to configure the SSID and password of my Wi-Fi router. That was the problem. I haven't configured that earlier code. I haven't configured the Wi-Fi IP address and password. That's what it didn't connect. It didn't show on my code on my network connection. I just forget to I just upload the code without configuring the code. Okay. So always remember this here in this code section, in this part of the code, you have to set the you have to set the SSID name and the password of the Wi-Fi network to whom it is connected. So there are two modes of the Wi-Fi. One is the AP mode, another is STA mode. So in STA mode, the IoT system is connect to your Wi-Fi network, and in AP mode, it acts as a hotspot itself and connect to your and you can connect your phone to this. Okay, and it can work in both ways simultaneously at the same time. So it can connect to your Wi-Fi network, and you can also connect, and it can also act as a hotspot as well at the same time, and you can also connect your phone to this. So it can act as a both thing. You can act as a either thing. Okay. So and for that you have to set thing like if you are using the AP mode, like here this is the AP mode code. Okay. So I can name it as a home automation and set the password, so it will act as a hotspot, and I can connect my device to this hotspot. Okay. Here is the STA mode. So I have to set the IP sorry, I have to set the SSID and the password of my Wi-Fi router. So I have to set it. That's why earlier it was not detected. Geo fiber. Let me check my Wi-Fi SSID name. Hmm, what was my Wi-Fi SSID name? I think it was the Geo Fibers. Yeah, Geo Fiber 4G. 1, 2, 3, 4, 5, 6, 7, 8, 9, G. So you have to say the SSID and password in the code as per your Wi-Fi network. Hope my Wi-Fi Geo fiber, I think fiber is in capital. Here it is not showing on my desktop. Let me check. Yeah, Geo fiber F is capital. Yeah. So I have this is my Wi-Fi IP address and this is my Wi-Fi SSID 4G and 1 2 3 4 5 7 8 9 0. Yeah, this was my SSID and password. So I have configured the SSID and password. I have to re-upload it again because earlier it was in wrong configuration. So let's wait for the uploading. So this is the STM mode. It will connect to the thing. Okay, and if I so let me tell you the connection in between that. So this is the connection. So this is the connection. Okay, this is the whole circuit diagram. Till the code is uploading, let's look into the connection. So here you can either use the one relay for controlling one bulb, or you can use the multiple relay, or you can add more relay to all these different GPIO pin, whatever the number of relay. If you want to connect more relay, more than 20, 30, more than 40, if you have the 100 relay, then you can add one more board and can use the ESP now integration to add more, or you can make a mesh network as well. So we will go into that mesh network and all those things later. If today, let's start with the simple. In the next session, I will tell you about creating the mesh network of the home automation system or using the ESP now protocol, where it can communicate with two devices and act as a radio switch without using any kind of Wi-Fi network, SSID, home Wi-Fi network or router or any kind of internet connection. Okay, that will also a great thing. Okay, so we will tell it later. It is compatible with that thing. Okay, so here I can attach the fan here, and I can attach the fan controller here, or I can attach the relay here, and all these relay are connected to the signal pins are connected to here, and all these V in pin, the power pin connected to the 5 volt, and ground pin connected to the ground pin, and the bulb neutral are connected to each other, and that sorry, bulb live wire connected to each other and goes to live, and the bulb neutral wire connect to the each relay normally open pin, and the neutral wire of the power line connected to the neutral so common pin of each relay. Okay, like this. Okay, so this is a circuit diagram. You can take a screenshot of this circuit diagram if you want. I am enlarging it, so you can take the screenshot for the future reference, or you can also check the article. It will be published on electronics for you. So yeah, now you know the total circuit diagram, how you can add more relay. So let me re-upload the code because we have configured the Wi-Fi. Okay, Geo. I am making mistake again and again in the code by setting the wrong name of the SSID of my Wi-Fi. It was the Geo, and the G I have a strong entered the wrong. I have to re-upload the code again. Sorry for that. I forgot the SSID name and password of my Wi-Fi network, and that's why it happened. Yeah. So now the code is uploading. So here, let me to explain the code a little bit. So I am using the pin number 33 to control the light, and I have connected the relay to the pin number 33, as you can see earlier in the here in the camera here. So let me show you the side by side. Where is the code? So this was the code that we are uploading. Yeah. So I am uploading side by side. So this is the relay module I am connecting with to the pin number 33. This pin number 33 yellow wire here. You can see here in this place. You can see the yellow wire here. Oh, sorry, yellow wire here that goes to the signal wire of the relay module. And you can also connect another light to the pin number 4 or other pin, any pin that you can also connect the fan controller to the pin number 5 or pin number 21, a speed controller to control the speed of fan. Then I have defined the fan speed and all those things. Then this is a dashboard. So we are creating the dashboard, and we are making the HTML and JavaScript file to create the dashboard of different buttons to create the UI like this. There are two ways. You can, if you know the HTML and CSS, then you can create the and JavaScript, then you can create beautiful dashboard using the HTML code, or you can use the ESP dash. There is a ESP dash library which you can use the create the dashboard without having the knowledge of any kind of HTML and this kind of thing. Or there is another way, you can download the dashboard templates out there in the market. There are lots of beautiful IoT dashboard templates out there. You can get it. You can also get it from the Chat GPT or the Grok as well. So you can ask them to create me the beautiful dashboard in HTML, CSS, JavaScript for the IoT. It will create you and you can use that. Okay. So anything, you can either use ESP dash to create the dashboard, beautiful dashboard like this. You can use your knowledge on the HTML, JavaScript, and the CSS. What I have used to create this kind of beautiful dashboard for controlling home appliances and light and speed, everything. Or you can use the template as well. Okay. So now my device is connected. As you can see, my device is connected here. So I'm copying the thing, and here I am pasting. I am pasting the IP address here. Oh God. Yeah, I'm pasting the IP address. This. I'm pasting the IP address here. So as you can see, the dashboard is open. Okay. And here is my light. Okay. So you can see it in the real time. I am turning on and off light. Okay. So there is no wired connection in between with this and this, in between my laptop and this thing. It's totally wireless. So when I can turn it on, the light will be turned on, and it is the AC. So I am turning the AC using my DC signal. See, light is on. See the magic of the IoT. Light is on. Okay. Here, light is on. You can see here, the light is on. I can turn it off. Light is off. Okay. So I can control the light. I can control n number of light wirelessly. Okay. I can turn it off. I can turn it on. I can turn it off. You can also add a different setting to control the brightness of this light as well. You can make a circuit for controlling the bulb light brightness as well using this. Okay. But here, uh, what I am doing, it's using the fan to control the speed of the fan rather than the bulb. So you can modify the code. You can make the code accordingly. Okay. So you can see I can control the light. I can set the timer. After that second, it can turn it on. It can turn it off automatically based on the timer. Okay. So in the photo booth here, you can see I turn it on and the light is on. I turn it off in the real time and the light is off. It's happening in the real time. See, light on, light on, light off, light off. It's real time. I can control n number of light refrigerator, and I can set the automation system as well by entering the after this number of time at this time you have to set it off. It will set. I can turn it on based on the temperature, based on the sensor. So that what we can make like here. I can make a touch switch. Suppose that I want to make a touch switch where I can touch some particular switch and it will turn on. So I can use the touch switch here. I am uploading the code of touch switch. So first let me explain the things. Let me show you the demo, then I will explain the things in more details. Okay. So I am uploading the touch switch. So I am making the touch switch IoT switchboard. So when I touch it, it can turn it on, turn it off, a smart switch. And I can also control it with the phone as well. I can also control it with voice as well. I can connect it with my Alexa as well. Okay. So lots of automation things you can make using this, and you can, and the whole device size is very small. You can one a small switchboard which can able to control whole home and office because its capability of having the n number of GPIO pins, a lot of GPIO pin here on the board that no other board will profile in this side, and a lot of sensor integrated. So I can control the things based on the sensor. Like if the temperature rise, temperature down, then it will turn off the AC, turn on the AC. Or I can also use the light. There is a light sensor as well. So I can do the automation based on the light. Like if there is night, then the light will or intensity will automatically increase with the intensity of light or decrease with the intensity of light present in the outside, or you can turn it on and off based on the day and night situation, or based on the light availability or not a light. There are lots of things can be done. Okay. So here the code is uploaded. So I am using the proximity sensor. So whenever I go near the pin number, what the pin number I have defined here? Yeah, pin number 4. It will turn it on and turn it off. Okay. Whenever touch that. Okay. Whenever touch that pin number 4, it will turn it on, turn it off. So let me upload the code again. That time code didn't uploaded correctly. So while uploading the code in the Indus mode, you also keep this enabled, the CDC enabled, and the upload mode internal USB. Otherwise, you might face the problem. It will turn off the USB if you don't enable these things. Okay. So let me explain this. So for the touch thing, there is inbuilt touch sensors on this. There are 10 plus touch sensor on the board itself. So you can make the 10 plus touch switches and you can control the light with the touch. And there is a 10 plus touch gesture that these touch pins are can be used as a gesture and proximity as well. So you can also add using the, you can turn on and off using the motions or proximity, or you can make a contactless switch. You don't need to touch it. You just need no, you have to just bring your finger near that switch and it will turn it on, the contactless switch. But that will help in the situation like the COVID or such situation where the lots of public hand need to be touched. You can make a contactless switch where it can turn it on and off without any need of physical touch. Just go near that, bring your finger near that, and it will turn it on and off. Okay, so you can use that as well. So here is the demo of that. Okay, so let me show you this thing. Okay, how do I maximize it? Yeah. So here you can see the serial in the serial monitor. You can see the touch events or proximity events, and this is the bulb. Okay, so as you can see, I am not touching. I am making the touch contactless touch switch. Okay, so I just go near the pin number 4, and it will turn it on. Okay, this bulb will turn it on. I just go and touch. Don't even touch. I just go near that pin number 4, and it will see. Yeah, on, off, on, off, on, off, on, off. Okay, like this. It's magic, like magic. Okay. So I just go near this. I don't need to touch. I just go near this touch switch, like a magic. So it has a 10 plus touch switch. So you can make a smart touch switch board. And in the market, those touch switch board, they don't have the Wi-Fi. They don't have anything. They're just simple touch switch board and they cost you a lot. Let me show you the cost that uh, 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 it will cost you. Touch switch board. See. Let me show you the touch switch board cost. So this is 4,000, 3,000. And there is only 4 touch switch, and they are not Wi-Fi enabled. They are just simple touch switch. And using this board, you can not only make the 4 touch switch board, you can make the 5, 6, 10 touch switch board. You can control the 10 appliances, 10 touch switch board, design the 10 number of touch events and 10 number of touch switch board that will be able to control the 10 individual appliances with 10 number of touch. You can make it. They cost you 3,000, 4,000, 10,000. They don't even have the IoT thing. It has the IoT thing. So you can combine both things. You can control it with either touch or you can control it with the phone as well. Or you can design the multiple things, like you can control with the proximity, you can control with the touch, you can control with the IoT. It can act as a proximity as well. And its proximity is not only limited to this. There is another good thing is that if I connect the wire to this pin number 4 and bring that wire to the one touch switchboard on the top floor and same wire to the ground floor. So if I touch the switch on the ground floor, it will touch it will turn on the room light on the top floor, and I can also control from the top floor as well. So same wire, wherever it goes, can act all n number of wire that will connect to it. Act all those wire act as a touch switch. Okay, and it is not just a touch switch. It is not just you need to make it work behind the glass. So if you put the good enclosure, design the good enclosure and put it behind the glass, even that case it will work. I am showing you. Okay, so here you can see. So suppose that I have any kind of glass or something. What? Where can I get the glass? What? I don't have the glass. Let me try it with some kind of other thing. Okay. The thing is, I don't have the glass here right now. Okay, let's use this. So this is the antenna. This is the Wi-Fi antenna. Okay. So suppose that this is a glass or some kind of plastic casing. Okay. So even though, see, it is working behind the plastic casing as well. See, I'm not touching that switch. It is working behind the plastic casing. I just need to touch this and it will work. So even the thing is behind the plastic casing, like this beautiful plastic casing. This kind of beautiful plastic casing. Okay, it can work behind that. Okay, you have just put the wire in all those switch behind the plastic casing, and when you go near it, you can it will turn on. You can set in the code. You can program it accordingly. It can either turn it on and off based on the touch, or you can make it contactless touch. You just go near it, it will, or you can make a proximity or motion sensor as well. So it has all those capabilities. So you can go and check the Indus board data sheet. So on the website here, on the Indus board, you can go to the documentation and the data sheet, and here. In the data sheet, you can check here. All these pins are touch enabled. So I can make total number of 10 touch switches. Total number of 10 touch switches here. All these are touch enabled. And all these are proximity. I can use it as a proximity as well. So these are the sensor that is available on the board. I can use the RTC. I can turn it on and off based on the RTC, create a full automation system. I can use the acceleration. I can turn it on or off based on the vibration. So suppose that if you want to make a earthquake detection system or earthquake alarm with your home automation system. So when it feels some kind of vibration, like earthquake kind of vibration, then it will automatically turn on the alarm based on the that. Okay. You can turn the AC on and on based on the temperature. It has inbuilt temperature sensor. Okay, it has the magnetic compass, so it can turn and off the equipment based on the magnetic interference, magnetic flux around it. It can turn the on and off based on the light. Okay, you can turn and off using the gesture. So there is a touch switch. You can make a touch switch board with the whole touch panel, and you can make the gesture out of it. Like you write F, it will turn on the fan. You make the up arrow, it will speed the or speed. A lot of things can be happen. Okay, you can make a contactless touch. So a lots of things are there in the board itself, and you can design anything like this. I can simply touch it and it can turn it on. See, it's turn it on. See, like this. It can turn it on and off like that. Or I can use a web dashboard like this. I can use the web dashboard like it, my own web dashboard, and control it using the home phone. It can connect to your TV, it can connect to your phone, it can connect to anything that has a Wi-Fi, and you can control the things using that. Okay, all the things can be possible. So let's now go deep into the design details. We have seen the demo. Now let's go for the design. So on the design part, I have already told you the circuit diagram and the data sheet that I have told you. As per the data sheet of the coin, all these pin you can use as a touch switch board, and all these pin you can connect the relay module to control the relay module. So I touch the pin number this pin number 2, and it will control the pin number relay on the pin 43. You can map it according. Okay, you can add your own sensor. There are also sensor already there. Okay. So suppose that I want to use the context touch switch, then I can use the internal driver. It's inbuilt sensor, the touch sensor. So for that, I have to include the library called driver/touchpad. Okay, this library helps you in activating and using your touch sensor on the Indus board coin. Okay, after that, we have to define the pin number to which you connect the fan or relay, whatever, to control the fan or any appliances like the AC appliances, like the any kind of appliances with the relay. Okay, like TV, fridge, refrigerator, whatever. Okay, you have to keep adding it, and then I have to check the touch interrupt, which pin and here in this port, touch interrupt in the bracket 4 comma on touch and 20. This 20 is the sensitivity. So I can increase the sensitivity and decrease the sensitivity. If I keep it 0, then when I touch that, it will turn it on and off. If I keep it above 20 or 35, then it becomes a touchless switch. So even I go near that, I bring the finger near that, I don't need to touch it. I don't even need to touch it. I just go near that and it will turn it on and off. Okay. Or I can make it proximity by increasing the sensitivity to 35. So I don't even go to the near the touch like this contactless touch. I just pass away near the board like a motion sensor. I just enter the room and it will detect me and it will turn it off. You can use it a proximity sensor as well. And here in the code, after that, it will check if the proximity is detected or touch is detected or not. If that is detected, then it will it will turn on or on off, toggle the digital pins as a high and low, and that will result in turning on and off the relay, and that relay is connected to fridge, refrigerator, fan, whatever the appliance. That appliance will turn on. Here I have connected the bulb, so it is turning on and off based on my touch using the bulb. Okay, using the bulb like here. So after uploading this code, whenever I go near this pin number 4, it can turn it on like this. Sit on, off, on, off. So whole AC appliance is the AC circuits, is the AC appliance, AC bulb. I am controlling AC bulb with my fingerprint touch, and I'm not getting anything harm. So I am touching here, the bulb is on. I am moving the finger out, and the bulb will become off. Okay. So it's amazing. It's amazing. You just touch it, and you turn on and off. Okay. So you can add the delay as well. It's like if you touch one time, then it will turn off on and off quickly. If someone is playing with by touching again and again, then you can add the delay. If it is a repetitive touch, then it will turn off after 10 seconds, 20 seconds. You can add those kind of algorithm as well. You can add the time, you can use the RTC as well. Now go for the IoT thing. Now adding the IoT thing, there is like earlier I have told you, there are two modes, STA mode and the AP mode. In AP mode, it acts as a hotspot. In STA mode, it connect to the Wi-Fi router. But if you can use the both mode at the same time. So here I am using the AP mode. Earlier we are using the STA mode where it connect to my Wi-Fi router. Now I am using the AP mode. Okay. So this is the AP mode example. Okay. So I have named the device as a home automation, and I have set the password. We can set any kind of password. Okay. Then you have to define the pins for the light, fans, and whatever the pins that we have connected to those API appliances. And then here is the set of the HTML code. You can see these are the HTML code. It is the dashboard code. So I am showing you the dashboard. So I can copy it and run it on the online HTML compiler. I can run on the HTML compiler, and you can see my dashboard. See my dashboard. Okay. So here I am using the dashboard here. Like this, I have designed this dashboard in HTML and CSS file. You can design your own dashboard like this. Let me show. This is my dashboard for automation. I can add more switches to it. I can add more function to turn it on and off. I can add more slider bar to control the speed. I can add more seconds and timing frames to turn on or to add the automation to the system. Okay. I can do a lot of things in that by modifying this HTML code. So what in the HTML code? So I have using the 4 to 5 buttons to control the AC appliances on the button. So I have added the button class here. For light one, name that button class 2, button class 3. You can add, if you want to add more button, then you can add more button and everything. And based on that, and then that it will fetch the data for that button on the IoT boards. What the status? Whether one had touched, whether someone had toggled that button or not. If it had toggled, or if it had changed the speed using the slider bar, then it will return to the board, and here in the Indus board, it will check if the light is toggled on or off now. If the web dashboard has sent the command to on and off, then it will turn on and off accordingly. And same goes for the fan. Same goes for the fan speed, handling all those things. And and then we will set the server handle the client. You can also add the sensor to it that will also display the room light temperature, humidity, weather data. You can make the smart thing, a smart touch switch board, everything. You can make anything. Okay. So that's all for the today. You can check out our next session for making the ESP now, and also the mesh network based touch switchboard, and later next we will convert it into the indoor navigation system using this board. So lots of things are there in the lineup. So you can check the next week with me, and let's meet the next week. If you have any question, you can comment it out. Okay, you can put it in the comment. I will check the comment later and answer you there, or I will also take that question in the next session as well. Okay. Thank you, everyone. Thank you. And whole code and everything is there available on the website. Okay. हेलो एंड हो गया ये सेशन